Alright, section 1.3. Let's start off with this. What we're going to do today is we're going to talk about distance. Okay? Distance. And we're actually going to learn a thing called the distance formula. You may have been shown this in Algebra 1. I'm not sure. Yeah, I think you would be, okay, in Algebra 1. You may not have used it a whole lot. You might have learned it once real quick, kind of went off of it. I'm not really sure. But in here we're going to use the distance formula a lot. Not just in this chapter, but I don't know if I would say every single chapter, but I just remember teaching this for a few years that there's every once in a while it just pops up, right, all throughout the year. So this is definitely something that you need to know and know how to use. It's really not that hard. Basically, most of the time that I'm going to take up teaching this is to show you how we got the distance formula. I could just sit here and say, okay, the distance formula is blah, 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 and go through all that stuff. And I could show you what the distance formula is right now, but I'm not going to do that. We're going to work it out. We're going to come up with it kind of on our own. All right? I want you to see where it comes from. I don't want to just throw it out there and say, here it is. This is how you use it. Boom, we're done. You might like that, okay? But I think you're having a better appreciation for it when you see where it really comes from. So that's what I'm going to attempt anyway to do today. And let's go to a line. So let's just draw a straight old line going across like this. Okay. Alright, so there's a nice straight line. Let's say this line represents like a road, alright? And you're driving down the highway and you want to find out how far it is from one place to another. So here's a sign. You ever go down the highways, you see the mile markers, especially like on interstates. They're little green signs. Sometimes they even give you like every 1/10 of a mile. But a lot of times you'll see every mile, they'll tell you how many miles you went. So let's say, I don't know, you're at the 30, I'm just making this up off the top of my head. Let's say you're at the 32 mile marker, all right? And you're driving down the road and you want to go to McDonald's, let's say, all right? And you're hungry, right? You're on this long trip going to grandma's house or whatever, okay? We used to go to West Virginia. Well, I still go to West Virginia all the time, but both sets of grandparents lived in West Virginia, so we go to West Virginia all the time. And couldn't wait to go to McDonald's. So, you know, I'd see what mile marker it was and what the exit we had to go onto, and then I could figure out how many miles we had to go. That was way back before anybody even dreamed of the GPS. All right, you probably don't even remember when there was no GPS, do you? You probably figured there was always GPS, but it wasn't that long ago when we came up with GPS. Well, I didn't have anything to do with it. I just use it. So anyway, let's say you went up to, you know at the 50-mile marker is McDonald's, okay? The Golden Arches. There we go. There's a McDonald's, and you can't wait to eat, right? So you got to figure out how many miles is that to go from here to here. This is not really tricky. I'm not trying to trick you up or anything. I'm just trying to show you how simple it is and how to find the distance between two points, basically, is what we're looking for. So if you're just going a nice straight shot, if you're at the 32-mile marker and you have to get to the 50-mile marker to get to the Golden Arches, right, Mickey D's, then how many miles did you have to travel here? Or how did you figure out? What math did you do? You subtracted. Very good. You went 50, what? Minus 32. What's that, 18? Okay. So 18 miles to go. So around, I don't know, 20 minutes if you're driving, you know, maybe even a little shorter, maybe 15, 20 minutes, okay, depending on how fast you're going down the highway. All right, so that's not too long. I can wait that long, right, to get to McDonald's. So that's how you figure out how long it is. Now, what if you're going the other way? What if you're at McDonald's, you had to get to this rest area or something like that because you had too much soda, right, and you got to stop. So what if you're going the other way? You could just say 50 minus 32. Again, it's still 18 miles, isn't it? Okay, or you could do this. You could say 32 minus 50, but what's the difference between 50 minus 32 and 32 minus 50? This is going to be a negative, that's right. But in distances, do we really deal with negatives when we talk about how far something is? No, I wouldn't say, well, yeah, I live about negative 5 miles from here. Well, that would be silly, wouldn't it? Okay, it really doesn't make any sense. So what they do is this. In order to go both ways, in order to subtract both ways, we're just going to automatically make that positive. Now, what have you learned back in Algebra 1 that automatically made stuff positive? What did you do to something to a negative number? Very good, absolute value, all right? So technically, don't get too worried about this, okay? But technically, you could subtract either way as long as you put them in what? In absolute value. So instead of saying I traveled negative 18 miles, if I think of it as I traveled the absolute value of 18, negative 18, that still gives you 18 miles, correct? Thank you. Okay. Oh, good. Thanks. We've been looking for you. That's all right. Okay, so it's 18 miles. So does it really matter what order you subtract them in? Nope, doesn't make any difference at all. Watch, what I'm going to do is this. Let's get a little more algebraic. Let's call this x, but let's call it x1 because I don't want to call one x and one y. Since we're going horizontally. Okay, this is my x-axis. You remember that, don't you? Okay, x-axis, y-axis. So if I have x1, what could I call this then? x2. So how could I find the distance between these two? I mean, let's say I don't know this is 50 and I don't know this is 32. How could I find the distance between this point and this point? That's right. I could subtract it either way. Does it really make any difference? I could go x2 minus x1, or put an or. I could write what? x1 minus x2. Does it make any difference which way I subtract them? No. As long as my answer comes out what? Positive. Everybody got that? All right. That's pretty easy, isn't it? All right, cool. Now, we don't usually travel in this direction, but you could travel like this, couldn't you? All right, but it would be the same thing. But instead of using x's, what do you think we're going to use? Yeah, so if I wanted to get from this point to this point, okay, we'll call this y1, and we'll call this point down here y2. All right, if I want to find the distance between these 2 points, what do? Yeah, I could go y2 minus y1. Or I could write it what? y1 minus y2. Does it make any difference which way we subtract them? Nope, it doesn't. As long as we make sure that our answer is always going to be positive, it really doesn't matter which order we subtract them in. We good with that? Alright, so we did x-axis, we did y-axis. Guess what we're going to do now? Not z, but we're going to go, we're going to put them together. Alright, so we'll do an x and a y-axis. You did a bunch of this in algebra, didn't you? Put little arrows there. Does this bring back good memories or bad memories? A little bit of both? Okay. So this is my x-axis, this is the y-axis. I kind of like this stuff. It's kind of fun when you do this. So that's x and that's y-axis. Now, here's the deal. Let's go with a different color now. Let's go blue. What if I wanted to get from this point to, let's say about right there, to that point, and let's put a line in between them. Is that all right? So from here to here. Doesn't keep on going. It starts and stops. Okay, so I'm at one point and I want to get to the other point. So what do I want to find? I want to find out the what? The length of, or the what word we've been using? The distance, right? The length or the distance is perfectly fine, either one. The length or the distance between those 2 points. So I want to find out how long that line is, basically. Now, do I just say x1 minus x2 or y1 minus y2? Do I do that? No, because I got to go in 2 different directions this time, don't I? In order to get from this point to this point, I don't just go over, I don't just go up. I got to do both, don't I? I got to go over and what? Got to go up. All right, so let's do that in another color. Orange should be good. So we got to go horizontally. Tell me when you think I'm there. About right there? Okay. And then you got to go what? Well, I said horizontal. Give me another good math word. Vertical, right. Oh, I was off a little bit, wasn't I? Well, watch this. I can scooch it over just a little bit. Wow, didn't realize I was that far off. Your eyes can play tricks on you, can't they? See, isn't that cool with that program? I can just scooch things around all the time. Make it look all pretty. Alright, so what we're going to do here is this. Let's go back to the blue. This point right here, we'll call this point 1, we'll call this point 2. Alright? So if I call this point 1, I need to give it an x and a y coordinate. If I call this point 1, now I don't know, I didn't put the little marks there, I didn't tell you exactly how far over we went. I want to be very general, okay? So if I wanted to call this point something, if I call this point 1, what do you think I'm going to call the x and the y? Something that we used earlier. What do you think? x1. Yeah, so I'll call this point x1 and I'll call this point y1. Make sense? So, if this is point 1, guess what I'm going to call this point up here? Point 2. And so I can, that's right, I can call this point x what? 2 and then y2. Now you realize that doesn't mean it's being squared or multiplied by 2 or anything. It's just another way to label that point. Okay, so this is my x1, y1 point. This is my x2, y2 point. We good so far? Now again, what am I trying to do? What am I trying to do with this blue line? Find the distance, right? I'm trying to find the distance or the length of that blue line, right? People say, well, just take a ruler and measure it. No, you can't do that, okay? Because the measurements could be off. It's just we want to do it with the numbers that they give us. They didn't really give us numbers, though, did they? We just have x1, y1 and x2, y2. So how in the world? Look what I just drew right there. Does this look kind of familiar to you? A triangle. And it's not just any kind of triangle. What kind of triangle is it? It's a right triangle. Good. We actually have a chapter in geometry. The whole entire chapter is just about right triangles. Not just about triangles in general, just about a right triangle. Can you imagine? A whole entire chapter, like 6 or 7 or 8 different sections, just about right triangles. All right? And this is actually one of the things that you're going to learn even in that chapter, which is, like, I don't know, chapter 8 or something like that. I forget which chapter it is. But watch. This is a right triangle. Remember putting that little box there? You guys did that, didn't you? To show that it's a right angle, 90 degrees. Yep. Okay. Again, we'll talk more about that later on. So we have a right triangle. Now, what did you learn in Algebra 1? I bet you anything y'all learned this. Some kind of math stuff to solve for different lengths of a right triangle. Say it. Pythagorean Theorem. Okay? And tell me what Pythagorean Theorem says. A squared. See, now it's coming. Right. See, you had it in your head, didn't you? Summer didn't lose, you didn't lose it all in the summer. So it's a squared plus b squared equals c squared. Which one is the a? Does it matter which one of these sides is the a?
No.
You sure about that?
Is it the slanted one?
Okay, the slanted one. Okay, which one's that? Is that the a? That's the c. That's right. The one that's sitting there by itself. It's not being added up to the other two. That's the c. What's a big fancy geometry name for this? You probably learned this. It's called the hypotenuse. Very good. It's called the hypotenuse. You can write that down if you want. But this is the C, isn't it? So which one's the A, which one's the B? Okay. Yeah, it actually doesn't matter which one's which. Okay, as long as one of the, we call these the legs of the triangle. All right. The hypotenuse is opposite the right angle. Do you see that? It's always the longest side, the hypotenuse. The other two sides, it doesn't matter which one you call A or B. It doesn't make any difference. Is this coming back to you? Who's learned Pythagorean Theorem? Raise your hand. Let me see. All right, good. All right, good, good, good. I won't ask if you didn't learn it, okay? But this is Pythagorean Theorem. Watch what we're going to do, though. This A represents the whole length from here to here, doesn't it? And this B represents this whole length from here to here. But let's not use A and B and C. Let's actually put some other stuff in here. Well, you can erase it. I just erased mine. What's this point right here? That's a little bit tricky. Look, how did you get to this point? Well, we started here, didn't we? At the origin. Remember that word? And we went to the right. So how far did we go to the right? Now, we don't know how many numbers because we didn't put any little marks there to show us how far. But if I went over this far, what's the length of that? Right? Is it just positive x? Be more specific. Look at the other. Look at this point and look at this point. This will tell you how far you went over. Because how did you get to this point? How far to the right did you go to get up to this point? You went over what? How far? I want you to think about it. Come on. How did you get to this point up here? You went this far and then this far, right?
You went over and up.
Over how far?
To the right.
Is it x1? x1 is way over here. Okay, if you went this way, this is right underneath what? This x2. So how far to the right did we go to get to here? x2. Do you see that? For instance, if this point right here was like, I don't know, making this up. Let's say 5, 3, right? So what did we do? We started here, we went to the right 5, and then what? Up 3. So how do you get to this point? Well, you go to the right 5 and then down whatever, right? Okay, but we don't know it's 5, 3, do we? But we do know that it's x2, y2. So how far did we go? We went to the right, and then we went down. So how far to the right did we go to get to this line? We went x2. So that point's going to be x2, isn't it? How far did we go down? y1. Very good. Because that's, see this y1 right here? That's y1, that length. So what's this little length right here? It's the same as it is from here to here. So that would be what? y1. That's the trickiest part of seeing this. A lot of people have a hard time seeing that. Does that make any sense at all? All right, so that's that point right there. Now, what are we trying to do? We're trying to find the length of A and B, aren't we? We just talked about going to McDonald's and going 50 minus 32, didn't we? Okay, so if I want to find this length right here, let's do this in a different color. Let's go yellow. Watch. If I wanted to find this length right there, how do I find it? It's not 50 minus 32. What is it? x2, good, minus x1. So this point right here, the distance or the length is x2 minus x1. That's that length. Let's come over here and do the same thing with this. It's just we're going up and down. What's this length? Look where we are. We're at y2 here, and we're where? y1 down here, aren't we? So how do we find that length? It's just like going 50 minus 32, but this time it's y2 minus y1. So that's your A and that's your B, up for the Pythagorean Theorem. Is this making any sense at all? So what I try to do is I just try to find the length of this side, the length of the other side. If I know those two lengths, I can put it in Pythagorean Theorem and I can get me a nice little formula out of this using the Pythagorean Theorem. Because the distance formula basically is the Pythagorean Theorem. We're going to write down some crazy stuff, but it all comes from this, which is the Pythagorean Theorem. All right? So what would our A be? Remember I had the A in here and I erased it a little earlier? So this is our A. It's what? It's x2 minus x1. But what do we have to do in Pythagorean Theorem? We have to square it, don't we? So I show that squared by doing this. Let's keep going with the Pythagorean Theorem. Plus b squared. What's our b in this situation? y2 minus y1. So I put that in parentheses, y2 minus y1. And I have to do what to that? Got to square it. Why am I squaring these things? Because it's Pythagorean Theorem. Why in the world did I pick Pythagorean Theorem just out of the blue? Well, it really wasn't out of the blue, was it? It's because I'm using what kind of a triangle here? A right triangle. And I can use Pythagorean Theorem with right triangles. We good? Equals the length of this. We could call it C, but I tell you what, since we're finding the distance, let's call it, what do you think? D. Yeah, let's call it D. Equals D what? Squared, right, because I got to square that third length, square that hypotenuse. We're getting close, we're really close, to writing out the distance formula the way that you need to memorize it. Except they write it D equals. They don't write it D squared equals. I mean, you could write it like that, it's fine, but in the book, almost every book, they always write it D equals. How do I get this D by itself? How do I get rid of a square? Good. I get rid of a square by square rooting both sides, right? So if I square root this side, that cancels out with the squared. Wouldn't you agree? What do I have to do to the other side? Square root that. So I'm going to put the D on the left. Is that all right? Just kind of make it a little easier. So this is basically it right here. Put a big old square root, and then what's in the square root? x2 minus x1 squared plus, then what? Yep, y2 minus y1 squared. And that right there is the distance formula. I'll write it down. Distance, formula. And that's it. It looks real crazy. If all I did at the beginning of class was said, okay, here's a distance formula, this is how you use it, you'd look at this and think, oh my goodness, where in the world did that come from? But now you saw where it came from, didn't you? It basically came from what? Pythagorean Theorem. That's right. It basically came from the Pythagorean Theorem. All right. What did the what does this x2 minus x1 represent? Represents the A. The y2 minus y1 represents the B. All right, and then D is like the hypotenuse.
Please excuse
okay.
the interruption.
Tell you what, let's just do this really quick. I'm running out of time, but let's just make one up. Watch, I'll do this really quick. What if I said find the distance between these 2 points? Okay, distance equals what? Square root, right? And then this is how I set it up. I always put these blanks right here, and then I just throw the stuff in. Watch very carefully, watch. x2 minus x1. It really doesn't matter which order you subtract them in. So let's go like this. Let's go negative 1 minus 2. What's negative 1 minus 2? It's negative 3. Let's go 3 minus 5 is negative 2. Let's see what we get. This is going to be what? Negative 3 squared is 9 Negative 2 squared is 4. So this is the square root of 13. And just leave it like that. Okay, don't put it into a calculator. Just leave it like that. I'm fine with that. Let me give you some problems to do. And so it's pages 31, 32. Oh, that's all the whining about.
No, I couldn't write on my
Oh, okay. Number 13 to 32. Okay, so it starts at 13 and you go to 32. And this is section 1-3. Call it A because tomorrow we'll do part B. Call it 1-3A, all right? There it is right there. Have fun with that.